Okay, Assalamu alaikum. Today we are going to talk about the final task for fundamentals of computer systems. We are going to talk about two topics: operating systems and computer networks. So first of all, what is an operating system? You all know that we have operating systems on our computers, such as Windows or Mac iOS. These are all operating systems. On our phones, we have operating systems such as Android. So what does an operating system do, and what is an operating system? So this is what we are going to discuss today. So mainly two topics are there. So first of all, we have some operating system definitions. So a program is a set of instructions which is prepared to perform a specific assignment if executed by a computer. A program is not an active entity. Okay, a program is not an active. Active means that it will run by itself. A program is totally passive. Okay, a program is passive. يعني you cannot let's say Word document or Microsoft Word will not run by itself. You need to double click it, you need to initiate it. So a program is a passive entity. A process is an active program. Once you run a program, you will have a process. How do you know these processes? I can show you from here, from the task manager over here on my computer. You can see that these are the processes running now. These are the programs, the passive programs. They need these processes in order to run. So this is just the terminologies that we need to go through in the beginning. So what's the single programming environment? Single programming environment means that we have one process running at any time. One process running at any time. So the process will have a process birth. Let me put on the pointer. So a process will have a process birth, meaning initiating the process. The process will be running. If it needs input output, then it will run the input output over here, and finally it will go for termination. Once a process is running in a single environment, means no other processes can run, and this is quite a problem, because if your input output time is around 90%, then we're going to have a problem that the processes, the most of the time of the CPU will be wasted for input and output. Frankly, this is not a good way to run a program in a single programming environment, which is not that good. Now next we have multi-programming. Okay, so to understand the idea, we are talking about running more than one program. To run a program, you need a process. So we are not saying multi-processing, we are saying multi-programming, because multi-processing means it's a different word which is related mostly to running more than one CPU, more than one processor. So multi-processing is running more than one CPU. Multi-programming is running more than one process. Multi-programming is running more than one process. Here we have multi-programming and how it can utilize or use the CPU in a better way. So if you have a multi-processing diagram, you can see here is the process birth. The process is ready. Another process will be running. That process which is ready will be kept here. So once the running process needs input output, it will be blocked, and the other process will start running, and so on. So the program can run more than one process at the same time, theoretically, because it's running one process, but others are put on hold. So this is the idea. Next we have multitasking. Multitasking, computer users usually like to have more than one task, and I will go back over here. I will show you. This is called task manager. Okay, this is called task manager. Multitasking is running more than one task at the same time, like opening PowerPoint with Google Chrome and these things. This is called multitasking. Multitasking is only possible when multi-programming is available. In single programming, you cannot have multitasking. All of these are organized by the operating system. All of these terms are organized by the operating system. So a thread is basically parallel lines within the process. Now, just keep things in mind. Previously, when we used to have Internet Explorer, you wanted to open an internet web page, you will open one. You want to open another page, you will double click on Internet Explorer again and open another page. So you will have multiple Internet Explorer pages. All of these, each one is a single process. So they said if the process is running the same program, open threads. Threads in Arabic اللي هو الخيط. Okay, it's just like a thread. So you have multiple threads within the same process, and you can break down the operations into threads. Again, I will over here I will go to the task manager once more to show you in my performance here. So I have 4 cores, 8 logical cores. I have the processes are 243 processes running 3659 threads. Okay, so threads are multiple instances of the same process. Okay, so this is called multi-threading. Now, in terms of operating system, what is an operating system? So an operating system is just like a manager. It will manage the hardware. Okay, so an operating system is a software layer to abstract away and manage details of hardware resources. Here's your applications, here's your operating system, and here's your hardware. Now imagine you want to copy a file from your flash drive to the hard drive. Quite simple, right? Just drag and drop. If there was no operating system, you need to write a code that will go to the memory location, specified memory location in the flash drive, and take the contents and put it in a specified memory location inside the hard drive. So the operating system abstracts away يعني zooms out and removes all the small details that you don't have to worry about. So this is your operating system here. Remember, you know DOS is the first operating system. Actually, it was invented by Intel. Then we have the Windows, which is running over here. This is Windows in pink. Now in the normal nowadays, we have all of these are part of our operating system, such as the browser, TCP/IP, file system, installer, printing, Windows. All of these are our operating system files. Now here in this slide, you will see the benefits and applications for operating systems. Remember, there are application benefits and user benefits, so you need to think about these two together. These are the architecture features that affects an operating system, such as timer, clock operation, synchronization, memory protection, input output interrupts. All of these are the operating system should support them at all time. So how does an operating system know if a protected instruction is to be executed? We have 2 modes of operation inside any computer. We have the kernel mode and the user mode. The user mode is where you operate. The kernel mode is where the operating system handles the hardware. The user cannot access the hardware immediately. Yani from my computer, I cannot go to the hard drive and do something. I need to go do that through the operating system. Okay? So there is a kernel mode and user mode, and the operating system has high protection for the kernel mode, for the hardware. So the user cannot change anything in the hardware. If the user changes something in the operating system in order to change the hardware, mainly you will have some malfunction in your computer. So the clear picture of operating system structure: this is your hardware devices. This is our operating system. Our operating system will have the application interfaces, APIs, file systems, memory manager, process manager, network support, boot and initialization, interrupts and handlers, device and drivers, hardware abstraction layer. All of these are our operating systems. Then comes our user applications, which we use every day, such as Word document, Firefox, Chrome. Whatever application you are running on your computer is considered an application. So here is your operating system, and here's your user applications. Just keep in mind, without an operating system, if you want to run your computer, you will only have a black page, and you need to use command lines to do everything, which is not user friendly. The next topic we are going to talk about is computer networks. In computer networks, here just an introduction to show you how the computers are connected. Most of us, when you go to any new place, you ask your friend, oh, please give me the Wi-Fi password. Okay, Wi-Fi, what's a Wi-Fi? Why do we need a password? And what happens exactly? So this is what we are going to talk about over here. So computer networks connects two or more computers autonomously together. The computers can be geographically located anywhere. So we have different types of networks. We have the LAN, which is local area network. We have the MAN, which is the metropolitan area network for a small city, and we have the WAN, which is wide area network, depends on the geographical distribution. Network topologies, we have different types of topologies. We have the bus topology, which is this topology. We have the star topology. We have the ring topology, and we have the mesh topology. So this is an extended star, and this is the mesh topology. Each one has its advantages and disadvantages. For instance, the mesh topology has redundant lines, basically used for military and banking applications. So if one line is down, there are alternative routes to the information, but this one is an expensive one. The simplest one is the bus topology, but the bus topology, if the line is cut in middle over here, then you're going to have a problem. These will be two separate networks. So we have mostly in, let's say in our computer labs, we use the star topology because all the computers will be connected to a single switch over here. The same applies at your home. If you are connecting all to the same router, it's like a star topology. Yes, we don't have wires. Here we don't have wires, but it's the same idea. If the routers goes off or the switch goes off, then you don't have the internet access. So we have a lot of standards, and the most common standard for network is the IEEE standard. IEEE stands for Institute of Electrical and Electronic Engineers. They put standards for everything. Then why do we need standards? Because basically, if I buy a phone from China and I travel to the US, I want it to work. How do we guarantee that? If the phone, let's say, supports Wi-Fi 802, then I will go to the US, it will support 802, it will work without any problem. So this project began in 1980 February, and hence February 80, so 82, 802 came from February 2. So the OSI model is developed with the cooperation of OSI. So the definition aspects of networking related physical cabling, connectivity, error checking, and all of these things. So basically we have a model that will run from the wires up to the browser if you are connecting to the internet. So we will have standards for everything. So the OSI model have several layers, which is the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and finally the physical layer. So basically people need to memorize them. So in order to memorize them in order, so we can say all people seem to need data processing, or people do not throw sausage pizza away. So these are just ways to memorize them. You need to know them. We need to know these layers in details. So basically what happens is the application layer communicates with the application layer. The presentation layer communicates with the presentation layer. But in order to do this, the only two layers that actually communicate are the physical layers. You connect a wire between the two computers and they communicate. The other communication is done by encapsulating data. This is the encapsulation. This is your data. Encapsulation means putting headers and trailers to the data. Encapsulate in Arabic capsule mal dawa, you know it, right? So it's just like putting all the information inside the capsule and sending it away. So you have the destination ID, the control ID, the sender ID, the CRS, which is containing the error checking information. So all of these information should be there encapsulated within the network package. Next, we are going to talk about the MAC address and network address. Each device, each networking device has two addresses. A MAC address, which is burned to the device. Burned means it comes from the manufacturer. Okay, burned means comes from the manufacturer. And a network device, which is an IP address, which is a logical address that can be changed. How do you know your addresses? Just go here, go to command cmd. Okay, you can write IP config. IP config will give me my all the information about. I can write IP config /all config/all. Okay, so this is the full information about all the adapters in my computer. Okay, so this is the, let's jump over here to my Ethernet. This is the physical address, which is the MAC address. Since I'm not connected to the Ethernet, which is the wire, I'm not using it. This is my LAN address. Okay, and here you can see the connection specification. I'm using the 802. You remember the 802, which is 1980 February. This is the Wi-Fi. This is my physical address. This is my IP address from the university. Okay, this is the subnet masks and these things. All of these information are helpful when you are debugging a network problem. So you have the MAC address, which comes from the manufacturer, and you have a network address which you are going to get from your router. Network addresses are usually either dynamic or static. Dynamic means it will keep changing. So let's say you are here in Barka building, you get an IP address, you move to Saham building, you connect to another router, you are going to get another IP address, and so on. We have 5 classes of addresses. We have class A, class B, class C, class D, and class E, and each of them will have a range of addresses from 0 maximum to 255, and you can see it's an octet. Octet means 8 bits. It's called octet because it's 8 bits. 2 to the power 8 is 256. Okay, so we have different classes, and each class will have a specifications. As you can see over here, I put them all for you: class B, class A, class B, and class C. Why did not put class E? Class E and class D are basically not used and reserved addresses. Nobody is using class D and class E. This is mainly the topics we are covering over here. You can read the lecture notes, the task notes, and if you have any question, I will be happy to help you and support you in this matter. Hope to see you all soon on in semester 1, and take care and have a happy holiday.